Stan Gibilisco here, proprietor and operator of amateur radio station W1GV Whiskey 1 Good Vibrations at your service. To explain in a little more detail the phasing system or phasing scheme used with the pair of phased vertical antennas that I described in a video that I just made yesterday, a very simple phased vertical antenna system. Two vertical antennas, ground mounted with lots of radials, a quarter of a wavelength high electrically. For example, on 40 meters, that would be roughly 33 feet. You have to take about a 90 to 95% velocity factor into account when calculating the height of a vertical antenna made out of aluminum tubing, for example. But this is going to be assuming we have a perfectly conducting ground, and that means a whole lot of radials. The free space distance between these antennas is 1/2 of a wavelength. Now in free space you don't use a velocity factor. A half a wavelength, I believe, is something like 492 divided by the frequency in megahertz, and that's the figure in feet. For a half a wavelength, and I'm using 40 meters as an example, so that would be something on the order of 70 feet. You'd have to calculate it for yourself. I'm not going to waste any time here doing it, just dividing 432 by your favorite 40-meter frequency. These two sections are 3/4 of a wavelength electrically, 50 ohm coaxial cable. Now the velocity factor may range anywhere from 66% to 75%, depending upon the type of dielectric material used. Solid dielectric coax would be more close to 66%, whereas foamed dielectric coax 75%. 50 ohm coax. Now, in theory, if you have a perfectly conducting ground and a quarter of a wavelength vertical, you will get a purely resistive feed point impedance at the base of about, well, technically it's about 37.5 ohms. 37.5 ohms. I believe I said 37 ohms in the previous video, but that's more precise. Now, a 3/4 wavelength section of coax will behave just like a quarter wavelength section of coax. This characteristic impedance then being such that 37.5 is to 50, as 50 is to what you get at the other end of the coax. And I stated about 75 ohms, and we'll go with that figure. It may be just a little bit different. 75 ohms, 75 ohms. But what I didn't make clear in the previous video is that these two sections of coaxial cable, which have to be 3/4 of a wavelength, not 1/4, or they wouldn't be long enough to reach even to the center midpoint between the two verticals. You wouldn't be able to make the connection here. This right here is a T connector. You can get those, well, at least on the day that I'm making this video, April 28th, 2015. You can still get them at Radio Shack, but there are a lot of places you can get these. You connect PL259 coaxial connectors to them, and then you run your 50 ohm coax to your radio. Now these two 75 ohm impedances, what I didn't mention is that these are connected in parallel, resulting in a purely resistive impedance of about 37.5 ohms. If you just connected them directly with any old length of coax, first of all, you'd introduce reactance into the system, and that'd screw everything up. A half a wavelength long, or any multiple thereof, any integral multiple thereof, and you would get 37.5 ohms at the other end here instead of 75, and then when you connect them in parallel, you'd get only half of this, or about 19 ohms, a little under 19 ohms, and that wouldn't make a very good match to 50 ohm coax. But 37.5 ohms will make a reasonable match. Now in reality, you're going to have some imperfections in your ground no matter how hard you try to make it perfect. So this is going to be closer to, say, 40 or even 45 ohms. So this impedance here will also be closer to 40 or even 45 ohms. So whatever the situation, you're going to have an SWR no greater than 1.5 to 1 on this 50 ohm coax going to your radio. And for all intents and purposes, any standing wave ratio of 2 to 1 or less is every bit as good as a perfect match in terms of line loss and the way that most radios will accept that impedance. So I wouldn't worry, if I were you, about this slight mismatch. A lot of people get really worked up about SWR and insist on coming as close to 1 to 1 as they possibly can, forgetting that the real purpose of this system is not to offer a perfect match to 50 ohm coax, but to produce the directional gain that you want. Now these are fed in phase. As a result, you will get radiation and reception maxima perpendicular to a line connecting the antennas. If this line runs east and west, your maxima will occur in a northerly and a southerly direction, and you'll get a little bit of gain over a single antenna, approximately 3 decibels, with respect to a dipole, which would be the same gain as you would get with a vertical antenna like this over excellent ground. So that is the antenna phasing scheme used for this particular set of verticals. In all of its gory detail, as you can see, I have filled the page with details. Stan Gibilisco, W1GV, I hope you picayune detail maniacs are satisfied now. But now that I'm finished with all of that, there's no more yammering to do. I will simply say 73, which means best regards in ham radio jargon. Until next time, da-da-da-da-da-da. So long.